Hello, everyone. I'm making some videos to help you with your Module 1 prerequisite assignment in ALEX. The last one I'm doing for you here is about questions 9 and 10. Both of these talk about average rate of change. Average rate of change is something that it sounds kind of scary, right? Average rate of change. That sounds really complicated. But all average rate of change means is slope. So when you see the words average rate of change, I want your brain to replace that with slope. So this is just slope. It's so hopefully that kind of rings some bells. Slope. How do you find slope? Well, there's a formula for that. If it's been a little while and you're rusty, our slope formula looks like y2 minus y1 over x2 minus x1. That is the slope between the points x1, y1. Sorry, this is a little too close there. And the points x2, y2. The slope of the line connecting those 2 points looks like this. Okay, so that's just the slope formula, right? And so if we want to find the average rate of change of this function from x equals 4 to x equals 6, I really just want to find the slope from x equals 4 to x equals 6. Well, in order to find slope, I need 2 ordered pairs. I don't have x1 and y1 and x2 and y2, but I do have 2 x values. So I'm going to say, well, x1 is 4, and that means x2 is 6. There's no magic in which one is which. You can decide which one is x1 and which one is x2. I promise you'll get the same answer regardless of which order you do that in. Okay, so we're halfway there. We have our x's, but we don't have our y's. If you have an x value, how do you get a y value? You plug it in, right? We have a function here. This tells us how to get y from x. It's going to be 3 times x squared minus 3 times whatever x is. So if x1 is 4, then to get y1, I'm going to plug 4 into my function. So that means y1 is 3 times 4 squared minus 3 times 4. Now we just have to do the arithmetic. I'm going to start with the exponent here. 4 squared is 4 times 4. That's 16 minus 3 times 4. Now I can do these multiplications from left to right. 3 times 16 is 48. Minus 3 times 4 here is 12. Now I can subtract. 48 minus 12 is 36. That means the ordered pair x1, y1 is 436. And I'm just going to mark that as x1, y1. And now to find the other ordered pair, I know that x2 is 6. So to find y2, I'm going to take x2 and plug it in. So I'm going to get 3 times 6 squared minus 3 times 6. And again, we are going to fight through this arithmetic. The exponent first, 3 times 6 squared is 6 times 6. That's 36 minus whatever 3 times 6 is. Okay, 3 times 36. You can put that in a calculator. I believe that's going to be 108 minus 3 times 6 is 18. 108 minus 18 is going to be 90, I believe. So our second point should be 690. And that is going to be the ordered pair x2, y2. Okay, so now we have our x1, y1, and our x2, y2. Average rate of change is just slope, so I'm going to apply my slope formula to these points. So the average rate of change is slope, which is going to be y2, which is 90, minus y1, which is 36, divided by x2, which is 6, minus x1, which is 4. Okay, 90 minus 36, that's going to be 54 up here, divided by 6 minus 4, that's going to be 2. 54 divided by 2 is going to be 27, I believe. And so that is average rate of change. Excuse me. So the average rate of change, my slope is 27. Sorry, that got a little hard to read. Let me fix that for you. Okay. So again, average rate of change just means slope. Y2 minus Y1 over X2 minus X1. All right, so now let's apply that idea to this next one. Kareem launches a rocket straight up into the air. This table tells us the height of the rocket in meters and a few times t in seconds during its flight. Okay, so this table is saying that at 0 seconds, it was 0 meters high, so it launched from the ground. 2.3 seconds into the flight, it was 92 meters high. 4.6 seconds into its flight, it was 138 meters high, so on and so forth. And this should kind of make sense. Notice our heights go up and then they come back down, right? If you launch a rocket, it's going to go up and then it's going to come back down. So that makes sense. This 138 is kind of, I think, probably at the top here. Or at least it's close to the top, right? We don't have enough information to say if that's exactly the top, but it's going to go up and then come down. Okay, so we want to find the average rate of change for the height from 0 seconds to 4.6 seconds. Again, average rate of change sounds fancy. It just means slope. We want to find the slope from 0 seconds to 4.6 seconds. Well, that means x1 is 0 because, right, the seconds, these are our x coordinates, right? These are our x's, these are our y's. So x1 is 0 and x2 then is 4.6. So now, in order to use my slope formula, I'm going to need y values. So if x1 is 0, what's y1? Well, y1 is going to be the y value that goes with x equals 0. When x equals 0, y is 0. So that means y1 is also 0. Okay, well, x2 is 4.6. What's y2? Y2 is going to be the y value that's connected to x equals 4.6. So when x equals 4.6, y is 138. So that is going to be my y2. And what am I asked for in this problem? Slope. So to find our slope, I'm going to do y2, which is 138, minus y1, which is 0, all divided by 4.6, that's x2, minus x1, which is 0. We'll do our subtraction here, and we'll get 138 divided by 4.6. In order to figure out what that is, I'm going to have to put that in a calculator. My brain is not going to do that all by itself right now. I get 30. So that means the average rate of change is going to be 30 meters per second. And then we'll do the same process here in part B. Again, we want to find the slope from 9.2 seconds to 11.5 seconds. So this means x1 is 9.2 and x2 is 11.5. So y1 is going to be the y coordinate that goes with 9.2. When x is 9.2, y is 23. And then y2 is going to be the y value that goes with the x value of 11.5. When x is 11.5, y is 0. And so now we'll find the slope between these, and we'll do y2. minus y1 divided by, oops, sorry, did that wrong. My brain's looking at the wrong thing. Y2 is 0 minus y1, which is 23. There we go. Divided by x2, which is 11.5, minus x1, which is 9.2. So we'll do the subtraction here. We'll get negative 23 divided by 11.5 minus 9.2 is 2.3. And we're going to get negative 10. So overall, the slope is negative 10 meters per second. And that should make sense that this is negative, because our slope on this side is going to be negative. We're falling, right? When we go from 9.2 to 11.5, our height's going down. We're on this part, so our slope should be negative. In part A, we were going from here to here, we were going up, which means we were on this section, which means my slope was positive. All right, I hope that helps with the last couple of problems there in Module 1 Prerequisite assignment, and I will see you next time.